Welcome to the next session of the subject Engineering Mathematics. In the last session, we have ended question number 74 of classroom workbook. Now we will start the session with question number 75 onwards. Students, just go through the question number 75 of chapter 1, linear algebra. What it is? Consider the following system of linear equations. Three equations are given in three variables x, y, z. What it is? The value of k for which the system has infinitely many solutions is. So three equations are there in three variables. One coefficient is given as k. We need to find the value of k for which these equations have infinitely many solutions. Now, what is the condition to get infinitely many solutions? The condition we have is, basically the system of linear equations is represented by ax equal to b. So to get infinitely many solutions, the condition we have is rank of A equal to rank of augmented matrix not equal to number of variables. This is the condition to get infinitely many solutions for a system Ax equal to B. Now, when you look at the last equation, in the last equation, k is available on the right side, right? Now, let us recall one example. Suppose if I have equations like this, x plus y equal to 8, 2x plus 2y equal to 16. Now, basically, second equation is 2 times of first equation. So, basically, this and this represent same equation. As we discussed in the last sessions, this system has infinitely many solutions, right? So physically we have two equations on the board, but officially it represents a single equation. What it is? X plus y equal to 8. Now when you look at this equation, how many solutions are possible? Infinitely many solutions. The possible solutions are like this: x value 5, y value 3, x value 4, y value 4, x value 3, y value 5. In general, I can fix like this. Suppose when x is fixed to some number k, then this will be 8 minus k. So where k is any arbitrary real number, k is any arbitrary real number. Therefore, this system has infinitely many solutions. Now from this example, the point we need to discuss is that generally the system has infinitely many solutions when one equation is a constant multiple of another equation. Basically, this is 2 times of this equation. So you take any number of equations in any number of variables. If one equation is a non-zero multiple of another equation, such equations have infinitely many solutions. Now let us try to get this the result for k in this manner. Now let us write the equations. The equations are x minus 2y plus 3z equal to minus 1, x minus 3y plus 4z equal to 1, minus 2x plus 4y minus 6z equal to k. Now look at this equation and this equation. Now actually when you look at LHS part, this is minus 2 times of this. First multiply first equation with minus 2, you are getting third equation. So 1 into minus 2, minus 2 into minus 2 plus 4, 3 into minus 2 minus 6. Therefore, this is nothing but minus 2 times of this. Therefore, when you look at this as equation 1 and this is equation 2 and this is equation 3, therefore this equation 3 is minus 2 times of equation 1. This is minus 2 times of equation 1. So as per this result, this k is nothing but 2. Therefore, the value of k for which this system has infinitely many solutions is k equal to 2. So we need to understand one point. Generally the system has infinitely many solutions when they satisfy this particular condition, rank of A equal to rank of A slash B. It confirms me that the system is consistent. So consistent means they may have exactly one solution or infinitely many solutions. So to get infinitely many solutions, it should not be equal to number of variables. This can be done in the different way. That can be done like this. So here k is available in the augmented matrix. K is available in the augmented matrix. So you can find A slash B. So what could be the size of A slash B? Here the size of the quotient matrix A is 3 by 3. In that case, the size of augmented matrix A slash B is 3 by 4. Therefore, rank of this 3 by 4 should not be matching with number of variables. How many variables are there? Here the number of variables is basically this is 3. So for a 3 by 4 matrix, rank not equal to 3. When it is possible for a 3 by 4 matrix, maximum rank is 3. That is very clear, right? So for a 3 by 4 matrix, maximum rank is 3. For a 3 by 4 matrix, rank not equal to 3 means every 3 by 3 submatrix of augmented matrix has 0 det value. As K is available in the last column, include that column and include remaining 2 columns, whichever you like, and make the det of that matrix equal to 0. Say, for example, I can take this matrix. So augmented matrix is this. So that is, so the coefficient matrix 1, minus 2, 3, 1, minus 3, 4, minus 2, 4, minus 6, and right side numbers are minus 1, 1, K. So minus 1, 1, K. This is my augmented matrix. So therefore, since its rank should not be matching with 3, therefore every 3 by 3 submatrix of this has 0 det value. So as a sample, you can take 1, 1, for example, minus 2. You can take minus 2, minus 3, 4, and minus 1, 1, K, and make this det equal to 0. You will get K value equal to 2, like this. Note this. Actually, this is question number 75. Hope you understand this. Now let us move to question number 76. So in question number 76, the system of linear equations has been written in the form Ax equal to B. Matrix form is given directly. So what is the size of quotient matrix? 5 by 5. That means there are 5 equations in 5 variables. So the form is this: 0, 0, 0, 4, 13, 2, 5, 5, 2, 10, 0, 0, 2, 5, 3, 0, 0, 0, 4, 5, 2, 3, 2, 1, 5 into variable matrix, that is A, B, C, D, E, equal to RHS matrix. This is 46, 161, 61, 30, 81. So actually this is in the form Ax equal to B. Now here what is the size of A? This is 5 by 5. That means there are 5 equations in 5 variables. Now what we need to find? The value of C rounded off to the nearest integer. So we need to find this variable C. Now when you look at this, now these are system of linear equations. In the first row we have 3 zeros. Even in the fourth row we have 3 zeros. Basically this relates to D and it is related to E. So this is 0 into A plus 0B plus 0C, like this. So this will be D term and this will be E term. So but basically we want C value, but instead of finding C directly, better to find D value or E value, because you can see in the third row we have, this is the coefficient of A generally. So this is related to B variable and this is related to C. This is related to D and this will be related to E. Therefore, let us try to apply this equation, this row and this row, so that I can get a D value, E value. So when you go to this equation, from this when you expand first row, what you get is 4D plus, because 0A plus 0B plus 0C plus 4D. 4D plus 13E equal to 46. This is one equation. Now expand fourth row. This is 4D plus, this is 5E. This is equal to, this is actually fourth row. Therefore, this is 30. Now from these two equations, you can easily get the value of E. Subtract second equation from first equation. Subtract second from 1. So equation 1 minus equation 2 implies 4D get cancelled. You will get 8E equal to 16. This implies the value of E is 2. Now let us try to apply E value either in this or in this. Suppose let us try to replace E value 2 in the second equation. So in this case 4D plus 10 equal to this is 30. So 4D equal to 20. So D value is 5. Therefore we got D values as well as E values. Now let us try to expand third row because we want C value. This is related to C. So when you expand third row, my equations will be like this. So this is 2C plus this is 5D plus 3E. 2C plus 5D plus 3E equal to 61. So this implies 2C plus D value is 5. So 5D is 25. E value is, this is 2. So this is 6 equal to 61. This implies 2C plus 31 equal to 61. This implies 2C equal to 30. Therefore the value of C is 15. Anyhow, this is an integer value, so we need not round off to the nearest integer. So C is directly 15, it is an integer. Note this. So actually this is question number 76. Next we move to question number 77. Go through question number 77. So it is A is a 3 by 4 matrix. It is given that Ax equal to B is inconsistent. So inconsistent means it has no solution. What they ask is the highest possible rank of A is, options are 1, 2, 3, 4. The highest possible rank of A. What is the condition for inconsistence? The condition for inconsistence is rank of A should not be equal to rank of augmented matrix A slash B. This is the condition for inconsistence. Now A is a 3 by 4 matrix. In that case, the size of augmented matrix will be 3 by this is 5. Because one column will be extra, therefore here it is 3 by 4, this will be 3 by 5. Now to get the highest rank for A, let us assign highest possible rank for augmented matrix B. To get the highest rank for A, let us assign highest possible rank for augmented matrix B. When you take a 3 by 4 matrix, maximum rank will be 3. Therefore, its maximum value. So its maximum value, because this is rank of augmented matrix, it will be 3. So here rank of A should not be 3. Anyhow, this is 3 by 4 matrix. Therefore, the possible values of rank of A are, they can be 2 or they can be 2, 1 or they can be 0. Because 2 should not match with 3. 1 is not equal to 3. 0 is not equal to 3. Therefore, among these three, the highest possible value is 2. Therefore, the highest possible rank of A is 2. Just it's a simple condition that rank of A not equal to rank of augmented matrix. Note this. Next, let us discuss question number 78. Question number 78. For what values of alpha and beta, the following equations have infinite number of solutions. Three equations are given in the variables x, y, z. Alpha and beta are given in the last equation. Now we need to find the values of alpha and beta for which these three equations have infinitely many solutions. Let me write those three equations. The equations are x plus y plus z equal to 5, x plus 3y plus 3z equal to 9, x plus 2y plus alpha z equal to beta. Now, when you look at the options, let us go through the values of alpha. In first option, alpha value is 2. Second option, it is 3. Third option, it is 8. Fourth option, it is 7. So the values are like this: 2, 7, 3, 8, 8, 3, 7, 2. So alpha values are different. Even beta values are different. So if I find at least alpha value, I can get the answer directly. So let us try to find alpha value. So here it is given that they have infinitely many solutions, right? So here alpha is available in the coefficient matrix A. So my coefficient matrix is 1, 1, 1, 1, 3, 3, 1, 2 alpha. So the condition to get infinitely many solutions is rank of A equal to rank of augmented matrix is not equal to number of variables. This is the case to get infinitely many solutions. So these two must be same, but they should not match with number of variables. What does it mean? Rank of A should not be matching with number of variables. Number of variables. So this implies rank of A is not equal to the number of variables in this case is 3. Now this is a 3 by 3 matrix. For a 3 by 3 matrix, rank not equal to 3. For a 3 by 3 matrix, rank not equal to 3. That means the delta of this matrix is 0. For a 3 by 3 matrix, rank not equal to 3 means its det is 0. So make this det value equal to 0. Make this det value equal to 0. Generally, whenever det is 0, that means there will be at least one linearly dependent relation among rows or columns. When you look at this second column, this is 1, 3, 2. So 1 and 3 are matching with this 1, 3. So ultimately this must be alpha value 2. Therefore, in this case, column 2 matching with column 3. Second column is matching with third column. Or you can do directly find this det value, make this equal to 0. Another simple way is, since det is 0, there will be at least one linearly dependence relation. So when you look at second column and third column, more or less they will be same. Therefore, this alpha must be matching with this 2 value. Therefore, alpha is matching with 2. So this is the value of alpha. So option A is right answer. Option A is right answer. Now let us move to question number 79. So what it is, the value of k for which the equations 2x plus 3y equal to 0, comma 6x plus ky equal to 0 have a non-trivial solution. So we need to find the value of k for which these two equations have a non-trivial solution. Basically, this is in the form Ax equal to O. O means it's a null matrix because right side we have two zeros. So it is a null matrix. Therefore, this is a homogeneous system. Because RHS of every equation is 0, every linear equation is 0, such a system is called homogeneous. So non-trivial solution means at least one variable in a solution is not equal to 0. So as we mentioned in the last sessions, for a homogeneous system, non-trivial solution is possible only when det of this matrix is 0. Here why we were discussing its det value? Because the size of A is 2 by 2. The size of A is 2 by 2. So therefore here the size of A is 2 by 2. So non-trivial solution is possible when det is 0. This implies the det of this coefficient matrix. Basically this is 2, 3, 6k equal to 0. This implies 2k minus 18 equal to 0. This implies the value of k equal to 9. The value of k is 9. Because we have two equations in two variables. Non-trivial solution means rank of A should not be matching with number of variables. Non-trivial solution is possible when rank of A should not be matching with the number of variables. So here A is a 2 by 2 matrix. A is a 2 by 2 matrix. Number of variables is 2. For a 2 by 2 matrix, rank not equal to 2, that means its det value is 0. So when you make this det value equal to 0, you will get K value 9. So option C is right answer for question number 79. Next we move to question number 80. So the equations are this. Two equations are given, x1 plus 2x2 plus x3 plus 4x4 equal to 2. Second equation, 3x1 plus 6x2 plus 3x3 plus 12x4 equal to 6. So two linear equations are given in 4 variables. Which of the following is true about these equations? Option A, only trivial solution exists. Trivial solution means all variables are equal to 0. That is x1 is 0, x2 0, x3 0, x4 0. So when you replace all variables inside any one of these equation, it will not be satisfied. Therefore, trivial solution is not possible. Trivial solution means all variables are equal to 0. Therefore, trivial solution is not at all a right option. So option A is wrong answer. In option B, it is given that there are no solutions. See, when you look at this option, these equations, this first equation, this is second equation. So this is nothing but 3 times of this. Multiply this equation with 3, 3x1, 3 2 6, 3 1 3, 3 4 12, 3 2 6. So officially we have a single equation, x1 plus 2x2 plus x3 plus 4x4 equal to 2. So this is the only equation we have because this is the 3 times of this equation. So we have a single equation in many variables. So ultimately it possesses infinitely many solutions. Infinitely many means many solutions are possible, non-trivial solutions. Let me tell you one simple non-trivial solution. Suppose I can take x1 value 2, x2 0, x3 0, x4 0. So substitute x1 value 2, x2 0, x3 0, x4 0, you will get 2. Another possible solution is this, x1 0, x2 value 1, x3 0, x4 0, x1, x2, x3, x4, you will get 2. Like this, you can produce infinitely many solutions. So it is a non-trivial solution. Non-trivial solution means at least one variable in a solution is not equal to 0. This is x1 value, x2, x3, x4. Like this, you can set many values. You can set many values. You can assign randomly x1 value, your choice, x2 your choice, x3 your choice. Based on that, you can easily get the value of x4 so that it satisfies total equation. Therefore, it has multiple non-trivial solutions. Multiple non-trivial solutions. Like this, you can produce infinitely many non-trivial solutions. So the answer is option D. Multiple non-trivial solutions exist because this is 3 times of this. This is the end of the session. So with this, we have finished entire chapter 1, that is linear algebra. Thank you so much.